Let's see what this next question is. The function f is continuous and differentiable. Continuous and differentiable. Notice the other one had said continuous that one time. But now we're talking about both. In the closed interval 3 to 7, the table above gives selected values. Which of the following statements must be true? The minimum value of f on 3, 7 is 12. Well, not necessarily, because who's to say that it doesn't go down to 12 and then goes down even further and then comes back up to 16? It could totally do that. We don't know that it does because it's at 20, then 17, then 12. Then we know it hits 16, but we don't know what happens here in the middle. It could go down further before it goes back up to 16. We know that. We don't know if it happens here in the lowest value is 12, but it could go lower. So 1 is out for sure. There exists a c such that the derivative equals 0. Well, I do know that because if we see that we start here at 20, we end at 20. That means that our average change overall is 0. So there has to be another time in the middle that it equals 0 as well. And that's just a confirmation of Rolle's theorem, which is just a derivative or a takeoff of the mean value theorem, where the average change equals the instant change. Well, the average is 0, so the instant's got to be 0 somewhere in the middle. So that one is true for sure. F prime of x equals 0 for f for 5 is less than x to 7. So somewhere between 5 and 7, we're saying that it equals 0. Maybe. We don't know. Maybe that minimum value is 12, and it doesn't equal 0 here in the open interval. This is an open interval. Notice that it's not including 5 or 7. So what if it happens, what if f prime of x equals, or is greater than 0? Pardon me. Is greater than 0. That's saying that the slope is positive. Well, it looks like it's positive because it goes from 12 up to 20. But again, what if, just like in that first one, it goes to 12 and here's 16, but it still goes lower? That means that here, between that 12 and 16, it could be negative and positive. Even between 60 and 20, it could still go down and then back up to 20 and be negative and positive. We can have a mixture in there. So the only one that's for sure true is 2. 2 only is the only one that is for sure true. Because we don't know what happens in between. We know stuff does. And maybe it doesn't do a lot of changes. We can't assume it doesn't, though. Number 87. We've got about 6 more problems here to go. The figure above shows the graph of f prime, the derivative of f, on the open interval negative 7 to 7. If f prime has 4 zeros, so that means we got a 0 here, 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 and here. How many relative maximum? Okay, for something to be a maximum, that means that we are increasing before, or positive slope before, and a negative or decreasing slope after. Decreasing function and negative slope. So we're going up and then down, and in between we hit a max. Well, here we are positive, then we're negative. We're still positive here, then we're negative, and then positive. So how many times do we go from positive to negative? Well, I see that I'm positive in between these two places, so I'm positive, 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 and then I go to negative. So from this positive to negative, I hit a max. But the other twos would be mins, because we're negative and then positive, and then negative and then positive. So this is a min, and this is a min. And this piece in here is a fake out. It says I'm positive, I'm going to flatten out, then I'm going to be positive again. So that's actually a point of inflection. Something slightly different. So how many times does it happen? 1 and 1 only. The rate at which water is sprayed on a field of vegetables is, where T is in minutes and RT is gallons per minute. During the time interval, what is the average rate of flow in gallons per minute? Okay, so they give us the rate. So we're given R of T. And it's saying, what's the average R of T? The average value of R of T. Well, if we're asking for the average value of a function, that's going to be 1 over b minus a times the integral from a to b of that function. If we were to plug in these numbers, let's see, during the time interval from 0 to 4. So we're looking at the interval from 0 to 4. So this fraction out here is going to be 1/4. So it's 1/4 the integral of 2 times 1 plus 5t cubed dt. Now I can combine this all into one function if I pull this 2 to the outside. And that's really 1/2 if I simplify that. So I'm going to just multiply this function times 0.5, integrate it, and see what the calculator tells me it is. So we go to the calculator. The function is going to be 0.5 times, and we have a square root, so I go second squared, and that gives me my square root. And we have, what are the pieces here? 1 plus 5t cubed. In my case, it's going to be 1 plus 5 times x cubed. Close this off. We need to integrate it from 1 to 4 or 0 to 4? 0 to 4, and that is in my integral, or my interval, I should say, from earlier. So if we go to the graph, now we're going to integrate it, so we go second, calculate. We're going to integrate, which is number 7. The lower limit is 0, the upper limit is 4. Answer is going to be 14.691. C is your answer. Number 44. The table above gives the values of different differential functions f and g and the derivatives at x equals 1. If h of x equals this big beast, then h prime of 1. Okay. Well, let's kind of simplify this first and see what happens. H of x is really equal to, this is kind of some polynomial multiplication going on. We have 2f of x plus 3. And we got 1 plus g of x. So this is going to be 2fg plus 3g plus 2f plus 3. So if I were to multiply all this out, h of x really equals 2fg plus 3g plus 2f plus 3. Alright, well, let's see how this is going to simplify them. That means that h prime of x, we're going to have a product rule for this first half. It's going to be 2 times f prime times g plus g prime times f. And then we're going to add to that 3 times g prime if we're taking the derivative of this, and that's just a constant, so it just sits there, plus 2 times f prime, and then the 3 goes away to a 0. So to simplify this even more, we have 2 times f prime times g plus g prime times f plus 3 times g prime plus 2 times f prime. Alright, well, let's plug in what we got. This is going to be 2 times negative 2 is f prime, and g is negative 3, plus g prime is 4, and f is 3, and then g prime is 4 again. So we got 3 times 4. Is that right? Yes. Yeah, it is. Now we're doing this one, which is 3 times 4, 3 times 4. And then we got the last one here, plus 2 times f prime, which is plus 2 times negative 2. So that gives me 2 times 6 plus 12 plus 12 minus 4. So that's 12, 12, 12, or 36 minus 4 equals 32. Is that an answer? What am I missing? I'm missing some negatives here, I think. Let's see. 2 f prime g. Oh, this has to be a 2 here. And g prime f is 4 times 3. So I needed a 2 here. 2 times this piece. So I need to add another 12 to that. Plus 12. plus 12. That's going to give me 48 minus 4, or 44. D is the correct answer. What I didn't do is I didn't distribute this 2 to those two terms. So that's what I did wrong. But I knew it was wrong because when I looked at the answers, none of them were there. I trusted my work. All right. Whoa, skipped 2 many there. What have we got? We only got 3 left. Let's do it. The functions f and g are differentiable for all x. F of g of x equals x, and g of f of x equals x. That means that g equals the inverse of f. F of 3 equals 8. F prime of 3 equals 9. What are the values of g of 8 and g prime of 8? Well, first of all, I can cross out a and b, because if f of 3 equals 8, all you do is you switch the x and y for g, so g of 8 equals 3. Now, one thing to remember is if you're switching x's and y's, then g prime of x is really like a dy dx of g. Well, but we're switching x's and y's. So that's like saying f prime of y equals dx dy. Now if I were to flip all this around, that's like saying dy dx is equal to 1 over f prime of y. Well, f prime of y is really f prime of g of x. So it's 1 over f prime of g of x. So that's really what's happening. And f prime g of g prime of 8 then is going to be 1 over f prime of 3, which is 1/9. So the answer would be E. '91. A particle moves along the x-axis so its velocity at any time t greater than or equal to 0 is given by v of t equals 5t times e to the negative t minus 1. At t equals 0, the particle's at position. What is the total distance traveled? Okay, so we're talking about total distance. Distance equals the integral of velocity, the absolute value of velocity. We're saying the distance traveled from 0 to 4. So the distance traveled from 0 to 4 is this right here. Now, we don't really care where we're at when x equals 1, or when t equals 0, x equals 1, because it says, what is the total distance traveled from t equals 0 to 4? It's not saying where are you at, it's saying what's the total distance traveled. So all we got to do is plug this in, integrate it from 0 to 4. That's it. Super easy questions here at the end. So our function is 5 times x times e, which is second natural log, to the negative x. Negative x. So we're going to graph that. Then we're going to integrate it from 0 to 4. So second, calculate. The integral is 7. Lower limit is 0. And our upper limit is 4. The answer is 4.54. Did we do that correctly? Let's see, we have 5 times x and e to the negative. Oh, minus 1. So we gotta do minus 1. We gotta type that into our function. Alright, so here's our function. And we want to do absolute value of this because that's going to be a little bit different. So I'm going to do second insert. Now I'm going to do absolute value, which is in the math menu. So math, we go to num, and the absolute value is there. We got to do this. I forgot to put the minus 1 on the end. So Now we're going to put it there. Minus 1. Close this off. Include all that in the absolute value. That looks a little better. Just so you guys can see a better picture of what's going on. I'm going to change my y values to from the lowest. Let's say we should go as maybe 0 because we're not going to be negative. We'll go up to maybe 2. Okay, so we're going from 0 to 4. So we're doing this area plus this little piece right here too. So now to add those three areas together, I'm just going to do second calculate, and then my answer here. The lower limit is 0. The upper limit is 4. And what do we get? 1.82. D is your answer. Doo-doo-doo-doo. Last one of the night. Look at this. It's 11:06. I am so tired. I'm tired of doing these tests. Let f be the function with the first derivative defined by this. What value of x does f attain its maximum value on the closed interval 0 to 2? So it's saying, when does this hit a max? That's easier than you think, especially with a graphing calculator. So let's go ahead and graph that. We have sine of x to the third. Now the rest of this we can delete. We don't need any of that. So I'm going to graph this, but I need to see below and above the x-axis. And sine of anything is going to be between -1 and 1. So let's change our y values from, instead of 0 to 2, we'll just go from -1 to 1. It's kind of all over the place. So let's see what it's really asking us. It's saying on the interval from 0 to 2. So let's change that to 0 to 2. That will definitely change what we're looking at. So this window is just from 0 to 2. Okay. And this is the derivative that we have. So if we have the derivative, we've got to understand how is that going to help us. The derivative tells us about slopes. And we know that if we're trying to hit a maximum value, the maximum value occurs when we have a positive slope before and a negative slope after. So that's, here's the positive, here's the negative. So we're looking at this value right there. So that's the 0 that we want to figure out. What is this? We can do that by calculating. I'm going to calculate a 0. Second, calculate the 0. Now the left side here, I need to get pretty close. Got to be on the left side though. And then on the right side, we just got to go on the other side down to the negative. Guess it's probably about here in the middle. Looks like about 1.4645 or 465. Done, dizzle. Good luck on your AP test. Da, 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 da.